Today we are going to do section 2-8, two variable inequalities. And you will be able to graph a two variable inequalities. So the big idea is that when we're graphing an inequality in two variables, it's very similar to graphing a line. The graph of a linear inequality contains all the points on one side of this line and may or may not include all of the points on the line as well. So, what is a linear inequality? A linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. So, this line is the boundary of the graph. So we have a line that is on our coordinate plane, and that line is separating the two parts of our coordinate plane. This boundary, or the line, separates the two coordinate plane into the two half planes. One of these half planes will be the solutions to our inequality. In order to determine which half plane to shade, or which half plane will be our solution set, we need to pick a test point that is not on the boundary. So we're going to take a test point and check whether the test point satisfies the inequality. If the test point satisfies the inequality, then we're going to shape that half of the plane. And if it does not, then we would shade the other half of the plane. A good test point is the origin, 0, 0. And it's usually easy to plug in as long as it's not on the boundary line. So, we're going to take y is greater than 3x minus 1. And we are going to graph this linear inequality. So the first thing that we're going to do is graph the boundary line. Y is equal to 3x minus 1. Since this is in slope-intercept form, I know my y-intercept is -1. And my slope is 3, so I'm going to make a line from slope 3. I went up 3 over 1, and now I'm going to go down 3 to the left ones, just so I have the extension of my boundary line. And since my inequality in the original problem is just less than, we are going to have a dotted boundary line. Instead of a solid boundary line, saying that all of the points that lie on the boundary line are not going to be included in the solution. So, we're going to choose a test point. We're going to choose 0, 0 as our test point. And we are going to plug it into our inequality, y is greater than 3x minus 1. We're going to substitute x with 0 and y for 0 because our test point is 0, 0. So, is 0 greater than 3 times 0 minus 1? 0 is greater than 0 minus 1, which is -1. Since this statement is true, 0 is greater than -1, we are going to shade the region of the graph where the test point lies. So since 0, 0 lies on this side, we are going to shade this part of our solution. And we have now graphed a two variable inequality. Just like we graphed a linear inequality, we can also graph absolute value inequalities, just like we were graphing absolute value equations. We're going to solve for y in our inequality. So we have 1 minus y is less than the absolute value of x plus 2. I'm going to subtract 1. Negative y is less than the absolute value of x plus 2 minus x1. I'm going to divide by -1. So y is greater than, since I'm dividing by a negative, I need to flip my inequality. Negative, the opposite of the absolute value of x plus 2 plus 1. When we are graphing our absolute value, we found our vertex, which is opposite of C, D. So I'm going to take -2, 1 as my vertex and make a point. I also know that this is where my axis of symmetry goes. So I can pick points on either side of my axis of symmetry to make a table of values. I'm going to go with -1 first. So if I plug -1 into my equation, the opposite of the absolute value of -1 plus 2 plus 1, -1 plus 1 plus 2 is 1. The absolute value of 1 is 1. The opposite of the absolute value of 1 is -1. -1 plus 1 is 0. And I'm going to plug in 0. And 0 plus 2 is 2. The opposite of the absolute value of 2 is -2 plus 1 is -1. I'm going to reflect those points. And I am going to also continue my line out. I'm going to pick a test point. I'm going to pick 0, 0 because I know that it's easy. Oh, I'm sorry. When I connected my line for my absolute value, I made a solid line, but in my original equation, in my original inequality, I only have less than or greater than. So I need to have that to be a dotted line. I now can pick a test point. Still going to pick 0, 0. And 1 minus 0 is less than the absolute value of 0 plus 2. 1 minus 0 is 1, is less than 0 plus 2 is 2. The absolute value of 2 is 2. Yes, this works, so I'm going to shade the region where my test point is, which is everything outside of my absolute value. And that's it.